video, I'm going to walk you through all the questions on the weekly booklet number 1. So starting from question 1, it's a trigonometry question in A2, and it is evident by looking at those expressions. There are cot x and there are cosec x. So in part A, they ask us to rearrange this equation so that it is just in terms of cosec x. So the only term that we could change here really is cot square x, and we will be using the identities that you should have learned in A2 trigonometry chapter 6, the reciprocal identities, which in this case we'll be using the one which says cosec square x is cot square x plus 1, where if you make cot square x as a subject, it should say cosec square x minus 1 on the other side. So cot square x equals to cosec squared minus 1, and we could just put it into the cot square x, which will be cosec square x minus 1 minus cosec x minus 11 equal to 0. So which will have cosec square x minus cosec x minus 12 equals 0 as required. So that will be part A. So for part B, they would like us to solve the equation in the interval from 0 to 360, and they want us to give each of the answer in degrees to 1 decimal place only. So what we would like to do really is to use the equation that we have changed into and just take it on from there. So cosec square x minus cosec x minus 11 will be written into the one that we have there, which is cosec square x minus cosec x minus 12 equals to 0. And if you have noticed, the reason why we use it is because this is actually a quadratic equation. If you let y equals to cosec x, which will turn into y squared minus y minus 12 equals to 0. So let me just write in here. You don't need to do that if you could factorize it nicely by looking at it this way, but I'll just do it anyway. So make y equals to cosec x. That means y squared is cosec square x. That means the equation that we have in front of us, that will turn into y squared minus y minus 12 equals to 0. That will be y minus 4, y plus 3, when we attempt to solve that equation by factorizing. And you could change it back into cosec x straight away, so that will be cosec x minus 4, cosec x plus 3 equals to 0. And then since 2 brackets multiply equals to 0, that means either one of it has to be 0. That means you could write it like that. Cosec x, either cosec x minus 4 equals to 0 or cosec x plus 3 equals to 0. That means cosec x equals to 4 or minus 3. And then we could solve it from here. And this is the process where we could change it back into the ordinary trigonometry expressions, which cosec x is 1 over sine x. So sine x is a quarter, and here similarly sine x is minus a third. So bear in mind, we're trying to solve this equation from 0 to 360. We try our best to find all the solutions. So here we will be using the calculator, and we'll be using the solving function. I know that they say you shouldn't be using the graphical methods or numerical methods, but here they can't really tell. So if you're having a CG50, so what you could do here, you will be going to var, and then you will go to option, and then you'll be using cal, then solving, and then just type in the equation. The first one, sine x, so sine x equals to a quarter, and we want our answers from 0 to 360, so let's do that. So 0 to 360, and let's see. Let's say there will be more solutions. Okay, so these are what we have. So 14.5 and 165.5 to one decimal place only. So 14.5 and 165.5 degrees. Now the other one, so we're just going to use that equation. Oops, and we're just going to change it to minus a third. So 3. And then minus 1, so minus a third. Let's see what we have here. So this time we have 199.5 and 340.5. So these are the solutions that you should have if you're solving this equation, and we have 4 in total. So this is question 1 for you. And now let's move on to question 2. Okay, so question 2. So by the look of things, these are a calculus question, and these are the questions that we have in AS. So and the figure here, it shows the curve that given to us, which is y equals to 3/4 x squared minus 4 root x plus 7. And they just show us the graph starting from x greater than 0. X less than 0 is omitted from this graph. Of this graph is omitted. So it tells us that this graph goes through 411, and there's a tangent that to C at the point P, and they want us to find the equation of this line, show that this is y equals to 4x minus 9. Okay, so standard procedure. What we're going to do first is to find the gradient at that point. That could be achieved if we differentiate our original curve C1 first. So let's start off here. So y equals to 3/4 x squared minus 4 root x plus 7. If we want to differentiate, we would like to write it all into indices form. So root x will be rewritten as 4x to the power of a half. And here, let's differentiate. So you just bring down the power and deduct the current power by 1. That means we'll have 3/4 multiplied by 2, 3/2, and x only minus 2x to the power of minus a half. And then since we would like to find the gradient at that point P, so we would like to substitute the x coordinate into this, since it's just written in terms of x. So later on, in your A2 differentiation, you will notice that your gradient function is going to be rewritten in terms of not only x, but also in terms of y. So here you just need to substitute your x coordinates. So that will be 3/2 multiplied by 4 minus 2 times 4 to the power of a half. If you evaluate this, you should have 6 minus 2 times a half, which will be 1. So you will get 5. And then again, standard procedure. So if you want to find the equation of a straight line, you need a point. We got it. You need a gradient. You have it. So you just need to put it into y minus y1 equals to the gradient times x minus x1, all in brackets. So y minus 11 equals 5 times x minus 4. So we arrange it. Open up the brackets, you'll have y equals 5x minus 9 indeed. Okay, so that is the first one. Now the second one, they say they want us to find the area of the shaded region. So it's a irregular space bounded in between the curve starting from 1 and also this line, 3 things. So how could we possibly find this area? So what we could do is we could, whenever you see where the curve and the line intersect, in this case just once, the point P, if it's not on the x axis, you could drop it. You could drop a line to it, and then you could see there's a little triangle right here, which fill up the empty space here. So what we could do to find this area R as a big plan is to find the area between the curve from x equals 1 to 4 using integration. So we're going to integrate it from 1 to 4 of the original curve 3/4 x squared minus 4 root x plus 7 with respect to x. That will take up all the space here. So let me color code it. So this is the area here. And then we're just going to take it away from the triangle. Okay, so this is the big plan. So in order to do this, so obviously we need to integrate this by hand and then evaluate the limit. So what about the triangle? What we could do is you could see we just need the base and we need the height. We already get the height here because we know the y coordinate of P. So the edge here is 4, and all we need is to know what this coordinate is. And then in order to find it, all we need is we could borrow what we have from part A, y equals to 5x minus 9, and we just take it from there because this is the x coordinate. So we just make y equals to 0. If you make y equals to 0, then you have 5x minus 9 equals to 0, so x equals 9 over 5. So with this big plan and the numbers that we have, we should be able to find the area R. Okay, so let's do step by step. So the very first thing, so let's just integrate this with respect to x, and then we'll just put the limits afterwards. So 3/4 x squared minus 4 root x plus 7 with respect to x. Again, we should have just rewritten the root x in terms of x to the power of a half so that it will be easier to integrate. So standard procedure, add 1 to the power and divided by the new power. So the first one, the new power is 3, and then if you divide up 3/4 by 3, you get 1/4. The second one will be a little bit trickier. So the new power is 3 over 2. That means you will do 4 multiplied by 2/3, which will give you 8 over 3, I believe. And then you have the last one will change into 7x. Okay, you evaluate that from 1 to 4. Or if you want, you could just do that using the calculator from now. So let's just do that. So we have cal and then we have integration. So you have, let's just input it one by one. So you have input the original one, so 3/4. So we have 3/4 of x squared minus 4x to the power of a half, or 4 square root of x. So let me just input square root of x, easier, plus 7. We need this from 1 to 4. Let's do that. Okay, so this is our final answer. But the way that we're going to do this is that we will be substituting our limits first. So let's do that. So that is what you should do as well in the actual exam. So you're going to input your numbers here, and then right at the end, just put on the answer that you have printed on the calculator, which is 217 over 12. Okay, so this is the way that you should handle this definite integral. And then now going to the triangle, we already have all the bounds. We know the base. We know the height. We know that this is 9 over 5. This is 4. So in order to find the area of the triangle, that should be base times height divided by 2. So the base should be 4. Take away 9 over 5. Multiply the height by 11. Divide that by 2. So what we have is going to be 4 minus 9 divided by 5, multiply this by 11, divide this by 12 by 2, and you have 12.1. which means in order to find the final answer, you will have, so in order to find the final answer, what's going on? Okay. Yeah, okay, so in order to find a final answer, so you will have 270 divided by 12 and take that away by 12.1. Just finish it off. Okay. Something wrong. Yeah, I don't have the takeaway sign. So we have 5.98. So we need this answer to 2 decimal place. That will work out to be 5.98 at the end. Okay. So just take these two away. So the final answer we have here is 5.98. If you take these two away, 217 over 12 minus how much? It's 12.1. Okay. Moving on, question 3. So they say, it's a statistics question. They say that a person runs a website that allows people to register UFO sightings. Interesting. So he records the number of sightings each week and the total rainfall each week in terms of R. And for 7 weeks during the autumn, he calculates the PMCC for his data to be negative 0.9290. So part A, they want to test at a 1% significance level whether the correlation between the UFO sightings and rainfall is negative. State your hypotheses clearly. Right, okay, so part A, what we need to do is to establish our hypotheses. So we got null and alternative hypotheses. So the first one, so that is the standardized one. That means there will be no correlation, which will be represented by this symbol here, rho. So rho is 0. And then since we're testing for negative correlation, so rho should be less than 0. Okay. And in order to finish the rest, we need to go to the formula booklet. So let's go. So since there are 7 days, that means our sample size is 7. And our 1% significance level, that means the number that we are looking for here is 0.8329. Okay. So we're just going to say under H0, be formal, and we're going to write down our critical value. The critical value that we have will be R equals to negative 0.8329. So bear in mind that we are doing a negative correlation test. So whatever that we have on this table, we're going to use the negative version of it, which will be minus 0.8329, which works out our critical region for this test under 1% significance level. That will be in between -1 and -0.8329. And since our data, so the data that we collected is -0.9290. That means it lies in the critical region, and that causes us to reject H0 since we have some significant evidence. So what we're going to write is that we have sufficient evidence to reject H0. That shows there are negative correlation between these two things. Between S and R. So let me just give it a shot. Okay. Right. Okay. So for sign from B to E, these are all 1 markers. So these are all explanation questions. So I'm just gonna talk about it verbally. So for the first one, they say suggest a possible reason for any such correlation. So really, because if there are rainfall, that means probably it is quite cloudy, and there's not much things that we could really look into. So that will hugely impact the UFO sighting. So that is possibly one of the reasons why there is a huge strong negative correlation. So part C, so he plans to model the data using a negative regression model. State given a reason whether the PMCC is consistent with his choice of model. So the answer is yes. So it's consistent to his choice of model because the value R is really close to -1. So it's minus 0.9290. You can't really get better than that in reality really. So question D, state given a reason which variable will be the response variable. Okay, so response variable is usually the variable that we put on the vertical axis, and then the other one is the independent variable on the x. So which one should be the variable that we put on the vertical one? So in this case, it should be the UFO sightings. The reason being it is really impacted by the total rainfall. So this is the variable that is always in response to what is being occurred. So that's why for question D, the answer should be S, the number of sightings each week. So question E, so he determines the linear regression equation as such as equals 6.4, take away 0.1 R. Interpret the gradient in context. So it's a standard phrase that we always use. So we always start from the horizontal variable, in this case R. So you will just say as R increases by 1, and in this case S will decrease by 0.1. And then in order to put it back into context, so you will say that as the total rainfall each week increases by 0.1 millimeter, by 1 millimeter, sorry, then the total sightings will decrease by 0.1. And if you want to, you could change it. So you could change it so that the numbers work out nicer. So you could say as the total rainfall increases by 10 millimeters, let me just write it down briefly. As R increases by 10 millimeter, then S, the total visits, the number of sightings, will decrease by 1. So it's just the ratio that we have there that you could play around with. So for question D. So this is question 3, the statistics question. And for question 4, we have a mechanics question here. So we have a particle P pushed up along the line of greatest slope of a rough plane. So rough plane indicating there will be friction since we're going up. Straight away, we know that there will be friction going this way. And that means we will be using the formula that we have there, which is friction equals to mu R. Okay, so moving on. So it is pushed by a horizontal force of magnitude x. So the second sentence is not really helpful. And then the last sentence, the plane is inclined at an angle alpha, which they tell us the alpha is having this relationship, tan alpha is 3/4. That means if we just have a right angle triangle for alpha, we have 3 and we have 4, and the hypotenuse is 5. That means it works out sine alpha is 3/5, cos alpha is 4/5. And they tell us that the coefficient of friction is 1/2. Okay, and the acceleration, which means we're accelerating upwards, is going to be 1.45. And they ask us to find the value of of X, the horizontal pushing force. So let's draw a big force diagram to work with. So we have friction already indicated. Value X here, the horizontal force. We also have the contact force because it is in contact with the inclined plane and the weight. Okay, and then these are all the forces. And the second question we have now is which force we should decompose, which force we should resolve. So since this force is moving parallel to the plane, so we want all the forces either parallel or perpendicular to the plane, which means all the horizontal or the vertical force need to be sorted. So here, let's just work with the angle alpha. So here, since this is an alternate it is angle in alternate angles. That means this is angle alpha as well, and then this one here is also angle alpha. Okay, and then so we're just going to resolve these. So this first one, the weight component, we could dissolve it into these two. So this one is going to be mg sine alpha. This is mg cos alpha. This one, same case. So with the arrows, so we're just going to start from this dot and go back inwards. So here and here. So this is going to be in terms of angle alpha. Right, okay, so this is going to be x sine alpha, and this is x cos alpha. Okay, so what do we have here? So the first one, we need to know the reaction force. So reaction force is in the perpendicular plane, which will be R itself, x sine alpha, and mg cos alpha. So we could just resolve perpendicular to the plane, and we will have R as x sine alpha and mg cos alpha combined. So we just add these up, x sine alpha plus mg cos alpha. And then the other one, so that will be parallel to the plane. And we have three forces there, and then they tell us that it's going to be F equals ma since. So that's fine. So let's do that. F equals ma. So it is going to be accelerating upwards. So we have the driving force x cos alpha, take away Fr, take away mg sine alpha, that equals to ma. And since the friction is mu r, so we could just substitute that into it. So if x cos alpha minus mu loss of r, so x sine alpha plus mg cos alpha minus mg sine alpha equals to ma. And we know that the mass is 2, the mu is a half, and we know the sine alpha cos alpha, and this is the position where we just substitute all the numbers. So we have x multiplied by 4/5 minus a half, x multiplied by 3/5 plus mg cos alpha. So that will be 2g multiplied by 4/5 minus 2g 3/5 equals 2 times 1.45. So what we need to do here is to make x the subjects. So you have x as 4/5 minus 3/10, 2 times 1.45 plus 2 times g times 3/5 plus g times 4/5. Okay, so half and the 2 cancel out when you open up the brackets. And yeah, put this on the other side. We have all that divided by 4/5 minus 3 times 10. So just put this all in the calculator, and it should give us the answer at the end. So let's do that. So we'll have a fraction, so 2 times 1.45. Take away 2 times 9.8 times 3 divided by 5 plus 9.8 times 4.5. And then we have 4/5 minus 3/10. Oops, what happened? Let's check. 2 times 1.45. 2 times 1.45 is 2.9 indeed. 2 times 9. Let's see if there's anything that I've omitted on the first one. 2 times 1.4. There's nothing wrong. Oh. Oh yeah, it should be add here. Okay, yeah, it should be plus. If it's plus, then it should work. Yeah, it will be x equals 45. Okay, sorry I made an error, but concept-wise, it is fine. So this is question 4. And finally, question 5 is a bonus question. So I'm not gonna talk about question A, it's just solving the equation. So starting from question B. So it tells us that OP is in terms of B. OP is equals to B, and then there's an area of a rectangle here. They want us to express the area of this rectangle in terms of B. Okay, so the equation of this curve is 9 minus x squared. So if I want to find this height, that will be the y coordinate. That will be, if you just substitute b to it, so that will be 9 minus b squared. So that's why the area of this rectangle is going to be part b, 2b times 9 minus b squared. That will give you 18b minus 2b cubed. Okay, and now C, hence find the value of B so that the area is at the maximum. So again, if I want to find the instant where it maximizes something, if it is not a trigonometry equation where we could see easily, we need to differentiate that. So here we'll just differentiate this, d by db. So we have 18 minus 6b squared. Make this equal to 0. So we have divide everything by 6. 3 minus b squared equals to 0. B squared equals to 3. B equals to plus or minus square root of 3. And then since we cannot take b is a length, so b cannot be negative, so b is square root of 3. Okay, so there's only one unique answer. But in order to check if it's going to give us the maximum area or not, we're just going to differentiate this one more time. So differentiate our original expression. Don't differentiate 3 minus b squared. The original expression 18 minus 6b squared. That will give us just minus 12b. And then, yeah, no matter what you substitute in, you will get a negative answer. So here, there you have it. Because it's less than 0, that means that this value of b equals to root 3 must give us a maximum area. Right, moving on. So now we're going to consider another function, g of x, as x minus 3 all squared plus k. This tells us that when these two intersect, that means we want to equate them when they intersect, show that the equation is 2x squared minus 6x plus k. Right. Okay, so let's do that. So we're just going to equate this. 9 minus x squared equals x minus 3 all squared plus k for question D. Open up the brackets and we arrange it. So we have 2x squared minus 6x. The 9's got cancelled. Plus k equals to 0. That will be question D. And now question E, they tell us that now these two are just going to intersect just once. Find the value of k. Okay, so if they intersect just once, given that this is a quadratic equation, that means the b squared minus 4ac must equal to 0. So this is going to be the clue that we're going to work with. So b squared minus 4ac equals to 0, and then just put in the numbers. We have minus 6 all squared, minus 4 times 2 times k equals to 0. So we have 36 minus 8k equals 0, and we'll have k as 9/2 at the end. So there you have it. These are all the questions that we have from question 1 to 5, and I hope you find these useful. So starting from now on, so after each week, I'll be publishing a video that will walk you through all the questions from question 1 to 5, and so feel free to use these as your revision material. Thank you.